Unit 4 deals with work, power, and energy. In some classes, they would also add simple machines to the mix. That's usually reserved for a unit somewhere around there, because now it's just a little bit the same. It's in that same vicinity, that same idea of the simple machines and how the energy works with it, and it's a different work when it works with it. So work, power, and energy is the topic of conversation. Everything that we've done with force still has to be looked at and remembered. It is important that we know those parts are still there. Those equations are still there. Some of the equations are fairly simple, and then there's some other things. So the other part becomes what we look at is to analyzing the motion of the objects. Now we're going to look a little bit more at some of the other parts. And that becomes the analyzing the motion a little bit more, predictions about the final state, how it's going to look at the end, what it's going to look like in the middle, and some of those. Now, the other thing is that in the motion and Werk, you see that I changed the spelling of Werk so that we are able to mentally make that shift. And that actually is done on purpose. And so that when we talk about work, a lot of times our brains go to thinking, oh, my job, and oh, I'm doing a bunch of work, homework, and some of those things. Well, Physics Werk is different. And in all reality, spelling Werk the way it is to hopefully have us mentally make that switch in our brain that we're talking about something else. But it's not my original idea. This is something that when I was in grad school, the professor used this idea, and I thought it worked really well, actually. I thought, wow, that's not a bad idea to teach it by saying it a little bit differently. And now, a little bit piggybacks on the whole using a little bit of a kind of a Germanish accent by calling it Werk, kind of giving the W a V sounding to it. Instead of an OR, more of another part of it. So it is just a little bit different. With that, it's just a way to, again, really it's a tool for you as a student to be able to make that separation in your head. So one of the other bigger parts of this is, I think, instead of looking at acceleration a lot more, is with motion and the Werk energy idea, is we're going to start looking at velocity much more as a much more common practice. So there is a certain amount of energy in Werk that is required to get an object moving. There is certain amounts of energy that is required to keep the object moving. the amount of energy that an object has is dependent upon the velocity, the mass, which then helps us determine some work. And we can also determine some of that based on the height as well. So we kind of take a little bit of a sidestep and not worry as much about acceleration, but more about location, displacement, and velocity. When we look at forces, we usually were just worrying about, the force, the friction, the acceleration that the object had. Well, we're going to still worry about the force, but now we're going to add a little bit of something to it that the work requires a force and a displacement, but the third key ingredient is the cause. And I think we haven't talked a lot about the cause. We've been just kind of looking at the effect, not worrying about what made that start to move. We're just like, okay, it's moving. Now what? Now there must be some sort of displacement for the object to have work done on the object. And we do work on the object. And I think that's another part of that we need to also think about, is that you are doing work upon the object. You are the cause of the force and the force causes the displacement. We now can explain, okay, an object is moved. Why did it move? I pushed it. Why did it not move as far as it should have? That's the effect part. That's the pulling it back and going, okay, I know that this object has this much mass, this much normal force, there's frictional force, I can find out what it is. And therefore, based on how hard I push this object will go a certain distance because I have pushed it this hard. I have put this much work based on a force over a displacement. If you put a little bit of a force, don't expect a very large displacement. But a little force over a large displacement does do work. Some people prefer the lots of force, small displacement. You're still going to get some work done. It's just a matter of how much work you want done. You got to maximize your force and you got to maximize your displacement. So, work done by a constant force is defined. The distance moved multiplied by the component of force in the direction of the change in displacement. Now, I use cosine here, although sometimes that tends to change depending on the fact that it's sometimes there. Sometimes it's sine. I've seen it a couple times where we use the sine of the theta because that's how the displacement works itself out, is really what it comes down to. The SI system for Werk is the joules and not the bling bling kind. It is, the namesake goes to James Joule, and it is the same joules that are studied in chemistry, in thermochemistry, because it's the same guy who gave us both. The joule, and not the bling bling kind, 1 joule, and not the bling bling kind, is equal to 1 Newton meter. So that's newtons times meters. So every now and then I've seen a couple physics people that will have do, and then they will have the equation for work after it. A lot of times we don't, I've also seen the equation usually is used in most 9th grade physical science or physics classes is without the cosine present. And the use of the cosine really comes down to, does the object move at an angle? Because if there's no angle, what is the cosine of 0? 1. So if the cosine of 0 is 1, if it's at no angle, flat, it would just be 1. So 1 times any number is that number. So a lot of times that part of it is eliminated from the equation. So, and I like to use a W with a subscripted E. 1, because again, we're talking about Werk. 2, it does not get confused with watts. Okay? It does not get confused with watts. And watts is a capital W as well. That's the label for a power thing. And so that's an important part of kind of putting that all together.